Hi everyone, welcome to chapter 4. Got a kind of short lesson here with mathematics in it. This is an exercise in vocabulary. So I'm going to talk about it briefly and leave you to ask me some questions because there are some concepts in here that are very close together. And if you don't take care to distinguish them in your understanding, you will forever get them mixed up. So I'll mention some potential pitfalls for you. Want to help you understand the meaning of the word census here, and population and sample. But census is where it's possible to gather data from every single individual in an entire population. For instance, the American government does a census of the population every 10 years. Um, and they literally knock on doors when people don't answer the census that they get mailed to them. So probably the closest we get to ever really knowing some of the data about people in our country. And yet, as much as they try, there's surely people that go unquestioned and their data does not get included, but it's the most comprehensive survey that is conducted in the United States. Um, we don't do a lot with census data because if you have every single number, there's no need to guess about anything. So we spend the bulk of our time dealing with samples that we take from populations. So you have to always be specific about the population of people that you are studying, the group from which you are drawing a sample. Okay. So we collect sample data, which represents an entire population, and we use the statistics about the sample to make an inference about the population, to infer facts about the population. Okay. Now, we know that samples aren't 100% representative of populations, but it's a beginning place. So make sure that when you draw conclusions about a study based on a sample, that you are only making generalizations to the population you drew the sample from. So let's say we're studying caffeine addiction, and we find that some people are more heavily addicted to caffeine than others. It's actually been proposed that there's a condition called caffeine dependence syndrome where someone is extremely addicted to caffeine, that it's truly difficult to get off of caffeine. There's a difficult uh, withdrawal period that's much more than a small headache. And so if we're going to make generalizations about our findings when we study this, we don't want to say, hey, the American public should avoid using caffeine. But because we didn't study the American public at large, we studied people who are addicted to caffeine. So that would be a smaller population. But we could, hopefully, if we design our study properly, make statements about caffeine addicted people, if that's who we drew our sample from, to look for signs of extreme dependence on caffeine. Okay, so when we decide to take a sample, I very rarely see the whole phrase sample survey used. So we'll just say when we go to take a sample, um, we want to very specifically define the population we're drawing samples from. Be very descriptive, or look for very detailed descriptions in questions that are posed to you. You don't want to make inference about a population that you're not sure of exactly how it's defined. All right. Um, and if our population is particularly large, then choosing a sample that will produce a valid study can be a challenge. All right. So we have to be very careful to say what we're going to be measuring and describe it exactly. And I want you to be mindful that this is the beginnings of what it is to design a statistical study, and we have to be very purposeful about all the choices that we make in the design of a study, or we might be wasting our time in producing results that have no validity. Okay, so bad ways to sample. This little definition at the bottom of the screen is possibly one of the most important definitions in the entire course. So please understand that we may have a non-scientific opinion about what the word bias means. But we want to make sure that you understand the mathematically technical definition of bias, okay? So if you just look at a friend and they're talking about how amazing looking their boyfriend or girlfriend is. You have to admit they're a little biased if they're dating the person currently. Um, and that's not an improper use of the word in just normal circumstances. But if we're going to say that data is, or that an estimate of the mean of a certain population that we try to judge from taking multiple sample is biased, what we mean is that it is consistently overestimating a number or consistently underestimating a number. And so when you mention that a statistic is biased, you have to say what direction it's biased in. Is it always overestimating or is it always underestimating the unknown value you're trying to figure out? So just know, for the AP people, you cannot mention bias without mentioning its direction, or you will not be given credit for knowing anything about what the word bias means. Okay. Now, we want to draw good samples that will represent a population adequately. And there are a couple of bad ways to do it. A convenience sample, where it doesn't take much money or effort to reach out and choose a group of people, can frequently be biased. There could be people that, if they're already together in a group, they might all have the same opinion, or they might all have the same response to whatever it is you are measuring. So convenience samples are what students do when they're having to do a project and design a study for themselves, that kind of thing. And we don't really have time for that project in this class, although it is an excellent learning tool for this subject. So this is like, I had a student who was asking people questions about their opinions, whether they prefer glasses or contacts, and for vision that was not perfect. And he stood at the doorway to his apartment building and asked people as they came in. Well, he certainly got a lot of answers, but that was considered a convenience sample because he didn't really have to do anything but stand there and wait for people to walk up to him. So that was basically considered a convenience sample. So the problem with it is, how does he know that this was a random sample? If he lives in a wealthy neighborhood, people might have more money, and that might lead them to choose one over the other consistently. If he did this in a poor neighborhood, he might be choosing a population that would say, oh, we like glasses better because we can't afford contacts. So convenience samples have to be very thoroughly scrutinized if they're going to be used at all. All right. Another way that could be a bad way to sample is a voluntary response sample. So if you put a notice on the board at the school and you ask people to respond to your survey, it depends on what the topic of your survey might be, but let's say you wanted to find out if students would be in opposition to raising ticket prices to basketball games. Well, I'm pretty sure there's going to be some individuals that have some really strong opinions about that, and those are going to be the people that like to go to basketball games. And they're all probably going to have a negative response to it, whereas you're probably not going to get very many people who don't go to basketball games to answer your survey because they're just not interested. They don't have a strong opinion. And so when you get voluntary response samples, you often get very polarized results. Often you get a lot of people with opinions in the same direction, or maybe you get two groups who are diametrically opposed because they both have strong feelings about it. So if you pick a highly politicized topic, like, should we change the income tax laws to be a fair tax? And if you don't know what that means, it's okay. It still makes the point. People that are strongly opposed to the fair tax will certainly want to respond. People who are very much in favor of the fair tax will want to respond. And so you're going to get these two groups. There may be very few people in the middle. If they were not interested in the issue or don't know anything about the issue, are going to give you opinions in the middle. But how many of those are even going to bother to answer? So there's only one place I can think a voluntary response sample would be an absolute must, and that would be in a medical study. It is unethical to force people to participate in a medical study. And so while you may have to rely on a voluntary sample, you would also have a very detailed screening process to make certain that the people that participate in your study are medically qualified to do so. And you might have a long list of criteria that they have to meet in order to be officially invited to participate, and there would be people that you would have to turn away. So keep that in mind. Voluntary response can produce an extremely biased sample in many cases, but is absolutely necessary in a medical case. All right. How to do this well, how to draw random samples. So random is the goal here. We would like to avoid personal bias. We don't want to handpick people to participate in a study because then it's no surprise when we get the outcome we were seeking. So if you have an opinion about your study and you know what outcome you'd like, it's nearly impossible to cancel out your personal bias and try and choose a sample that is adequately random without help. Okay, and that help has to be some kind of chance process. Examples of a chance process: rolling a die, flipping a coin, things that cannot be influenced by your personal opinions. Okay, so a random sample is a sampling technique that involves chance to make decisions about who's included. And I want you to notice the difference between the word random sampling and the very specific term simple random sample. This is abbreviated SRS in so many places that you need to be aware of this abbreviation, and you may use it in paragraphs and things. It's so common. So let's read this definition and see if you catch something in here that a lot of people don't. A simple random sample of size n is chosen in such a way that every group of n individuals in the population has an equal chance to be selected as the sample. Okay, so what this does not say, it does not say every individual in the population has an equal chance of being selected. It says every group of n individuals. So if we're taking samples of size 10, or a sample of size 10, then mathematically you could figure out, if you know how big the population is, or at least approximately how large the population is, you could mathematically calculate how many groups of 10 individuals could be chosen. And you want to make sure that your process of choosing them gives every possible group of 10 people an equal chance to be selected. Okay, so keep that in mind. That's not just every individual in the population has an equal chance, but every group of however big a size you're choosing has an equal chance to be selected. It's not a huge difference, but if the difference is needed for you to understand a question, then we'll be able to talk about it based on this explanation. All right, so random number generators are another way to choose numbers randomly, and calculators, computers have all kinds of methods of creating random digits. AP statistics used to include a table D in the formula sheet, which was a table of random digits, and they have since gotten rid of table D in favor of including a table in any question where it is asked to, where they ask you to use a random digit table. So where it refers to table D, just understand you'd be given a collection of random numbers from a table to execute this procedure on. So if we're going to use technology, not a random digit table manually, you're going to make sure you know how many people or how many things, individual, doesn't matter if they're living beings or not, how many items are in the population. You number them, give each item its very own number, and then you can use a random number generator, like your calculator has this feature. RandInt, RANDINT is the feature, and we'll see that at some point when we do some sample problems with it. And you have the computer pick a random number from 1 to n, and you have it do it n times. Now, if you're going to use a table, we're going to have a sample problem here in a minute that will explain this to you. Okay, so let's just briefly look at these. It says give each member of the population a numerical label with the same number of digits. So if you have 50 things in your population and you call the first thing 1 and the second thing 2 and so on up to 10 and 20 and 30 and 40 and 50, you can't just leave 1 and 2 and 3 all the way up to 9 as single digits. You have to call it 0, 1 and 0, 2. So they're all 2-digit numbers. That's what they mean. And they want you to use the shortest numbers possible. So if you don't need to have 3 digits, don't give 3 digits like 0, 0, 1 and 0, 0, 2 if you're only going to pick 50 things. Okay? So for the second step, the randomized part, we want to look at a sample problem to do this. So here is a list of, looks like hotels, okay? And they provided you a line from a random number table in this box right here. So this is line 130 from a random number table, and we want to choose a simple random sample of 4 hotels. So this would be 28 different hotels. If we really wanted to know how many samples of 4 were available, you've done this mathematics before, it would be 28 choose 4 combinations. But that's not the question they're going to ask you here, and we will review combinations and permutations in another chapter. But here's what they're going to do. See how every hotel has a 2-digit representation. And we're going to go through this line of digits. Pardon me. Such a sensitive mouse. And here they are. They've taken all these numbers and they've written them with a space every 2 digits. You don't have to rewrite it if you could just look at 2 digits at a time. So you would look at 69 and you would look at 05. And whenever you hit a number that's on one of these hotels, you would keep it. But see, as we go through this, 69 is too high to have a hotel, so we don't count that one. And then 05, well, we're going to be able to choose the Beach Castle Hotel. And then 16. Notice how when it's written this way, the 1 and the 6 are split. That's okay. They just split it 5 digits at a time to make it easier to read. But that would still be 16, as is shown down here when they divide them every other number with a space in between to make it easier to read. So we would then choose Hotel 16, which is the Radisson. And we keep going. 48 is too big a number. 17, we could choose that hotel, the Ramada. 87 is too high. 17, we've already chosen Hotel 7, and presumably you can't choose them twice, so we're just going to skip over it, and so forth. 40, 95, all of them too high. 17, we've already gotten. All of those numbers circled in red are too high, and then we get to the number 20, and that one is low enough to be chosen, and we have our set of 4 hotels, and we can stop. So you keep going until you get the right number of items in your sample. And I like the way they put a circle and slash through the ones they skip. You can put some other symbol, like a star, like they did, on the items that you choose. And they didn't mark out 17. You probably could have, but they were acknowledging that they can't choose the same hotel twice. So we are choosing without replacement here. It wouldn't make sense to choose the same hotel twice if we're trying to choose samples, okay? And so as long as we're not allowed to pick the hotel twice, then 28 choose 4 would be the number of samples of size 4 that we could choose. Alrighty, so that is one sample method, and you would actually draw on the numbers here with the circles and the slashes and the stars and things to show how you had collected your 4 numbers. Okay, so there are different ways to do random sampling. We just showed you one that was pure random sampling. And so there are other ways, and I particularly like the sample in the book for stratified random sampling. So let's see what it is first, and then we'll talk about the problem. The basic idea of sampling is straightforward. You take an SRS from a population, and you use that to figure out information about the whole population. But just being able to randomly pick every possible group of however many you're choosing, stratified samples are divided by grouping, and they call them strata. Think of them as rows if you were to arrange some things in like a rectangular arrangement. Choosing rows randomly and then randomly choosing items within those rows. So when would that be appropriate? You want to look at the sample problem in the book that talks about a lady that has a farm where she grows fresh flowers for the market. And I think they're sunflowers, if I remember correctly. And she grows these flowers in a field, and along one edge of the field there is a river growing. And the flowers closer to the river, or the plants closer to the river, grow more flowers than the plants farther from the river because they receive more moisture naturally. And so the plants closer have a higher production. And if this lady is trying to figure out how many flowers she's going to have to harvest, to send to market, but she can't get out there and count every stem, then she needs a way to sample. So she takes her giant flower farm and divides it into a grid. And so in this problem they give you, it's a 10 by 10 grid, and she divides it into strata. So the row of squares in the grid that are closest to the water is considered one strata. And each row, let's say there's 10 rows and 10 columns. Each row is a strata, and each row is one step farther away from the water, and so you would expect each strata to have less and less flowers as you move away from the water. So if we just choose 10 out of the 100 squares to count flowers in, then we may get too many flowers close to the water and not enough far away from the water if we don't stratify them. So if we divide them into the 10 rows, each row being one step farther away from the water, then we can, in each of the 10 rows, randomly pick one of the squares in the row so that we get one square that is 1 unit from the river, another square that is 2 units from the river, another square that is 3 units from the river. So we'd have, when we get to the 10th row, 10 individual squares, each one step farther from the river. And that would better represent the all of the different grids that have the potential to grow more or less flowers based on how close to the water they are. So please make sure you look at the flower example for stratified random sampling. So another way to break up a population, and remember we're trying our best to get a sample that represents the population as a whole the best we possibly can. So there's a cluster sample method where we take advantage of location or proximity of groups within the population, and we divide groups by geography. So I believe the sample in the book talks about an auditorium full of high school students. And let's say we have, like our chapel. In chapel, the seniors sit in the middle section in front, the juniors sit in the middle section behind, the sophomores sit to the left, and the freshmen sit to the right. That is, if you are the speaker and looking at the audience. And if we want to take a sample of students from the high school and we want to ask them a question, that age would change their answer, like how many credits do you have toward graduation? Obviously, freshmen would have lower answers than seniors. And so if we just take a random sample of the entire high school, we may get too many older students and not enough younger students, and our estimate would be biased. So if we divided them by clusters, so let's say all the freshmen, each row is a different cluster, and we take one from each row in the freshman section and one from each row in, or homeroom, maybe we should say, in the senior section, and one from each homeroom in the junior section, then we'd be sure to get a sample that is spread evenly over the 4 grades. And we would do that dividing based on nearness. So all the seniors are near to each other, so that could be a cluster. So read that example in the book. Of course, they're not talking about our chapel that we're familiar with, but it's a good picture of what cluster sampling is and when it is to be used and when it's to your advantage to use it. Okay, so why should random sampling be the solution to our problems with bias in picking samples? And the randomness takes the human equation out of choosing. So we will get more into the laws of probability in Chapter 5, but the laws of probability say that if you repeat an event over and over and over again, that probability can be established. The probability that an event will happen can be established using many, many events. So if you draw individuals from a population over and over again, that if you choose a large enough sample, it will represent the population significantly close enough to be a valuable estimate. However, we know it's not going to be exactly the same as the population. The chance of you drawing a sample that has the same characteristic that you're looking at as the entire population is exceedingly rare. And so samples are going to have margins of error, and the more we go through this class, the more we'll pin down how accurate our guesses are likely to be when we allow for a wide margin of error versus a narrow margin of error. Let me give you an example of where margin of error is frequently used. If you pay attention to election polls, frequently you will see, especially in like a big election like the presidential election, a list of how many people were called by the Gallup poll organization and asked about who they would vote for president once we get down to just two people. And they'll say, like in the last election, Hillary Clinton has a 49%. I have 49% of people asked said they vote for Hillary Clinton. 52% or 51% said they'd vote for Trump. And then they say in the fine print at the bottom, there's a plus or minus 3% margin of error in this data. Well, can we definitively say that Trump is ahead in the polls if it could be 3 more or less than his current numbers? That means his percentage could be as low as 48 or as great as 54. And then if you look at Hillary Clinton's number that I quoted at 49%, plus or minus 3% would be as low as 46 or as high as 52. So can we definitively say that one of them is ahead of the other with a margin of error of plus or minus 3%? And the answer is no. So we'll be talking about margin of error more and more specifically as we go through the course. And then lastly, of course, a larger random sample is going to give better information about the population than smaller ones with a certain limit imposed, and we'll worry about that limit later. Just suffice it to say for now, the more people you're able to sample, and I keep saying people, but that's not exactly correct. The more individuals in your sample, you could be dealing with people, but you could also be dealing with other living creatures. You could be dealing with, I had one student who conducted a study to see if off-brand Oreos have the same amount of stuffing as name-brand Oreos. And so her subjects were Oreo cookies. So they don't even have to be living things. So pardon me if I say people when I just mean subjects. All right. So things that can go wrong when you go to take a sample, you may not be able to reach some people in a population to include them in a possible sampling, and that would be undercoverage. Non-response, you're doing a phone survey and people hang up on you. That's a problem. Response bias. Let's say you have chosen your sample in a systematic way and you're seeing results follow that pattern of how you chose the people to begin with. So response bias can be a problem. And then just simply wording questions in a survey in a bad way. So for instance, let's say first I ask you when's the last time you went on a date, and then I ask you how happy are you with your love life. So I would think that the answer to the first question would definitely influence the answer to the second question. And so you might want to word those questions more or in a less leading fashion. How about this? If I say, you're going to vote for candidate A, aren't you? Well, that tells you, as the person who's answering the question, what the person asking wants to hear. And there are a lot of people who will simply give the answer that they think the interviewer wants to hear, regardless of their own opinion. So wording of questions is a very simple way to really screw up a survey if you're not careful. All right, that is what is in this unit, or this section rather, section 4.1, and we will discuss any questions you have about this vocabulary. I especially want to warn you about the cluster sampling versus stratified sampling. Make sure you pen down those two items in your understanding really well. Okay, thanks for listening.